Alright, welcome. In this video, I'm going to be working Algebra 2 Quiz 8.3, which is all about, kind of graphs of radical functions. I'm going to start with form A. This one's pretty quick, so I think we'll be able to move pretty fast through it. Find the x-intercept on the graph of y equals 10 minus 2 times the square root of x minus 6. Alright, well, the x-intercept on the graph of any function is the place where y equals 0. Or any place where y equals 0. So I'm going to go over here and I'm going to say x-intercept, that's where y equals 0. So 10 minus 2 times the square root of x minus 6 is equal to 0. And we're going to solve this just like we did last time. It's part of why we learned how to solve radical equations, so we could do stuff like this. So 10 equals 2 times the square root of x minus 6. Divide both sides by 2. Okay, square both sides. Okay, that does mean I'm going to need to check my answer. But I feel like I probably wouldn't, I wouldn't send you on a wild goose chase, searching for an x-intercept where there was none. X equals 31, just let's think about what's the value of y when x is equal to 31, and that's 10 minus 2 times the square root of 25. Yeah, that's going to be equal to 0. Okay, so that's good. That's an x-intercept because y is equal to 0. Okay, find the y-intercept on the graph of y equals that. Okay, well, a y-intercept, that's the place where x is equal to 0. So I'm going to say y is equal to 1 plus 2 times the cube root of 4 times 0 minus 8. Okay, the cube root of negative 8 is negative 2. Okay, so negative 4 plus 1 is negative 3. I didn't really solve an equation there. I just plugged in and evaluated an expression, so I don't need to worry about, checking my answer, plus, minus, anything like that. I'm just going to get y equals negative 3. Okay, the sketch of the graph of y equals 2 square root of x plus 1. All right, so I'm completely on my own. I don't really have, oh no, I've got a horizontal line there that I guess I could use if I really needed to, but I don't think I will. So what I'm going to do, I'm going to start with kind of the vertex of the graph because this is a square root. So, okay, the x-coordinate is going to be where x plus 1 is equal to 0. It's where I take the square root of 0. So that's where x is equal to negative 1. And y at x equals negative 1 is going to be 2 times that square root of 0 that I was looking for, so that's going to be equal to 0. Okay, so x is negative 1, y is 0. Whoops. So that's on the x-axis. Put that there. Okay, the graph is going to open up into the right because it's the square root of positive x. I mean, it's multiplied by 2, but I'll account for that later when I draw another point. Okay, I need to draw another point, and I'm going to need to put in a y-axis, I feel like, so I might as well just make that where x is equal to 0. So vertex, other point. It's going to be x equals 0. Y equals 2 times the square root of 1, which is 2. So I'm just going to go and draw in a y-axis through here. And just label that point with 2. And so I've got my 2 points, I've got the shape of the graph. It looks good. Okay, that's going to be a more than decent sketch. The only thing I could do to improve it would be label my axes, which is always good practice. Right, now sketching the graph of y equals cube root of x minus 2. Okay, well this is going to look like the graph of y equals cube root of x just moved down by 2. It's going to have a y-intercept of negative 2 if I plug in x equals 0. So what I'm going to do, I'm just going to kind of draw a cube root graph as best I can. Let's say, okay, well that's going to be at y equals negative 2, so I'm going to draw my y-axis in like that. 2. And I'm going to draw my x-axis in like right there. Okay, but I mean, you could do whatever you wanted. I don't even know that I need to see the axes. I didn't ask for axes. Might as well just find that point. Okay, but you could plug in x equals 1 and y is negative 1. You could have that point here. Okay, you could also say, all right, I think that point is going to be cube root of 8 minus 2 is equal to 0, so that'll be x equals 8. And you can see this is clearly drawn out of proportion, but that's essentially that's the shape of the graph. All right, write an equation that represents the graph pictured below. All right, first of all, this is going to be a square root graph because it's only, extending in one direction. The graph is starting right there at that point. So I'm looking at y is equal to some number times the square root of x minus h plus k, where h and k are the coordinates of that point at the edge of the graph. Okay, so in this case, h is equal to 0 and k is equal to negative 2. So, and then I'm going to use some other point that I know is on the graph. Okay, so I'm going to use 1, 1. So x equals 1, y equals 1. So 1 is going to equal a times the square root of x, which was 1 minus 0, minus 2. Okay, so that's going to just be 1a minus 2. So 1 equals a minus 2. A is going to need to equal 3. And so y is equal to 3 square root of x minus 0 minus 2. Okay. Now you might have been able to figure that out, I don't know, some less deliberate way, but that's going to be kind of that's the process I've been using to come up with equations for graphs of square root, cube root functions. All right, here we've got a cube root graph, right? And I know that because it's got arrows on both sides, right? It's extending in both directions. It's not having any domain issues. So I'm going to say, all right, kind of starting with the vertex is looking like here. It's at the point x equals 1, y equals 0. So I'm looking at y as some number times the cube root of x minus h plus k, where h is 1 and k is 0. And then my other point is 2 and 0.5. So I'm just going to say, all right, y is 0.5 and x is 2. A times the cube root of 2 minus 1 plus 0. Okay, so 0.5 equals a. So a is 1/2. Meaning that my equation is going to be y is 1/2 times the cube root of x minus 1 plus 0. Well, that don't need to write that. Okay, I've got myself an equation. Okay, number 7, find the domain of f. So f is 2 plus 3 times the square root of 4 minus x. Well, the domain is, what are the x's I'm allowed to plug into f? Okay, so I need this thing that I'm plugging in to the square root. The rule is square root, I can take the square root of a positive number or 0. So I've got 4 minus x, that needs to be greater than or equal to 0. So, you could solve this another way if you wanted. But I'm just going to add x to both sides and then just say, okay, well that means x is less than or equal to 4. And that's going to be the domain of f. The range of f is okay, what's going to happen with the y values here? Well, okay, I'm always going to have this 2 here, and then I'm going to add on 3 times the positive square root of 4 minus x. Okay, well, it's the positive square root, so that is at the very minimum 0. So at the very least, I have 2 plus 3 times 0. So you could say, the range is y is greater than or equal to 2 plus 3 times the square root of 0. Otherwise, if I'm able to take that square root and get a real number back, I'm going to be getting a positive number. Okay, so that's y is greater than or equal to 2. That's all for Form A. All right, now let's work Form B. So I'm going to start by finding an x-intercept and a y-intercept. All right, an x-intercept is a place where y equals 0. So that's going to be where 3 square root of x minus 7 minus 12 is equal to 0. So 3 square root of x minus 7 equals 12 divided by 3. Square both sides. Okay, so that means I'm going to need to remember to check my answer, add 7 to both sides, and get x equals 23. Now, asking you for an x-intercept, I don't think that's a situation I would set up for an extraneous solution, but I'm just checking. 23 minus 7 is 16. 3 times the square root of 16 is 12. Yeah, okay, that gives me y equals 0, so that works. Okay. I checked my answer on that one just mentally. So we're going to find the y-intercept on the graph of this radical function. So y-intercept, that's a place where x is equal to 0, so I'm just going to plug in x equals 0 and get y equals 5 plus 4 times the cube root of 0 minus 1. The cube root of negative 1 is going to be negative 1, so 5 plus 4 times negative 1 is 5 minus 4 is equal to 1. Now we're going to give a sketch of the graph of y equals 2 times the cube root of x minus 1. So I'm going to kind of start with the vertex or the center point of this, and that's going to be where x minus 1 equals 0. So that's x equals 1. And then y at that point is 2 times the cube root of 0. We're not adding anything on, so that's going to be y equals 0. So x equals 1, y equals 0. That's going to be kind of the center point of my graph. And this is positive 2 times the cube root, so it's going to look like just a normal cube root graph. It's not going to be upside down or anything. So I'm going to just kind of draw it like that. And, you know, to our simplistic drawing, I don't think the shape of cube root is all that different from the shape of square root, except for the fact that it's got this other half on the underside. Okay, we're saying that was x equals 1 right there. Okay, I'm going to need another point to give this some sense of scale. And since, okay, I've got my x-axis, I've got my curve, I don't really have a y-axis yet, might as well try to find a y-intercept. So I'll just choose x equals 0, and y is going to equal 2 times the cube root of negative 1, and that will equal negative 2. As good as I've got. Okay, that's my y-axis, and I'm going to label that as negative 2. Okay, and that'll be a decent sketch for us. Okay, we're really looking for, like, is the shape of the graph right, and is the location of the center point right? If so, we're probably going to give you credit. I'd like for you to label another point properly, but it's about the shape of the graph here. All right, now let's give a sketch of the graph of y equals the square root of x minus 3. Okay, so the vertex on this thing, okay, you could look at it that way, or you could say, wait a second, this is pretty simple. This is just the square root of x and then subtract 3, so all the y coordinates are going to get subtracted by 3, so it would just be shifting the graph of y equals square root x down by 3. So we know what that thing looks like. It goes about like that. And normally, you know, it would go through the origin, but if we just moved it down by 3, it's going to be down on the y-axis where y is negative 3. And I can draw in an x-axis at about there. Okay, I think that's going to need to be 9, right? Because if I take the square root of 9, that'll be 3, and subtract 3, I'll get y equals 0. Okay, so x and y. Okay, but you could have just as easily gone over here and said, okay, that's 1 and negative 2. You could label, you know, any points you want. Okay, but that's what the graph is going to look like. All right, for the next two, we're going to write an equation that represents the graph. And so the first thing is to determine, are we looking at a square root graph or are we looking at a cube root graph? And this one's going to be a cube root graph because it's got, you know, like 2 halves to it. It's square root graph's very, you know, it starts somewhere, it ends somewhere. But this one is just, you know, it doesn't have arrows on it, but I think it's kind of implied that this is kind of going forever in those directions. And what we're going to do here, I don't even remember what I was thinking about this. We're going to identify the center point. That's going to be over here where x equals negative 1 and y equals 0. Okay, oh yeah, we kind of set up the skeleton equation. Y is some number times the cube root of x minus h plus k, where h and k are the coordinates of that center point. So x equals negative 1, so h is negative 1. K is y equals 0, so I'll have that. Okay, I need some other point, and that'll be this one right here, x equals 2, y equals 0. So I plug in, wait a second, that's not x equals 2, y equals 0, that's x equals 0, y equals 2. So I plug in 2 for y and 0 for x. It's 2 for y, 0 for x. And then I'm taking a times 1 equals 2. Okay, that just means a has to equal 2. Now you could probably look at this and say, okay, like, hey, it went, I'll do this in gray, clear that other stuff out. Went over by 1, up by 2, so that means the leading coefficient needed to be 2. Okay, on the outside, you know, that's fine if that's how you approach that. That does work. Okay, I always take a very, solving approach in my class, but either way, the equation is going to be y equals 2 times the cube root, that's turning out 2 times the cube root of x plus 1. Then number 6, this one's going to be a square root curve because it ends right here at x equals 0 and y equals 1. So this is going to be y is some number times the square root of x minus h plus k. Okay, where h is 0 and k is 1. And my other point is 1 and 1.5. So 1.5 is going to equal a times the square root of 1 minus 0 plus 1. Okay, so 1.5 equals a times 1 plus 1, so a is going to equal 0.5. And that makes sense. Okay, again, using the other method, I went over 1 up by 0.5. So a is a half, and y is equal to 1/2 of the square root of x plus 1. Two more. Now we've got this function f, and we're going to find its domain and range. Okay, so first, with the domain of f, that has to do with, like, what are we allowed to plug in for x? So this x plus 2 thing just can't be negative, right? Because we're assuming that the output of f is a real number. So if I want that, I'm going to need this x plus 2 to be greater than or equal to 0. And that happens to be when x is greater than or equal to -2. Okay, and all right, the range. Okay, that's what's going to be tricky on this one. I was like, that seems a little easier than one of the other form, but I see what's going to happen here. Okay, y equals 4 minus 3 times the square root of x plus 2. Okay, so this is always going to be 4, but then I'm going to be subtracting 3 times something that's always positive. So I'm thinking y at the very, the least amount that I'm subtracting is 0. So y is going to be less than or equal to 4 minus 3 times the square root of 0, right? Because, if I had x being like 100 or something, or 98, I'd be taking 4 minus 3 times a number that's getting a little bit bigger. And so it can get, less and less and less. So this is where we're gonna have y is less than or equal to 4. And yeah, that's all for this quiz. That's all for this video. Thanks for watching.